Hi guys, quick lesson on basic trigonometric graphs. The first graph that we're going to look at is the sine function. So if I was to take my unit circle and our picture of the sine function, try to graph the sine function from here, we would be talking about the y values because the sine, as we know, represents the y values from a right angle triangle. So if I was talking to the about the 0 mark here, I would say that it's when my theta is 0, so if it's a flat line, I don't have an angle, so my theta is 0, so my cos theta, comma, sine theta, writing small, is going to be my coordinates. Okay, so if I was to look at when I move my angle up, so if I move around counterclockwise around the circumference, the first angle that I'm going to pick up is the pi over 6. And if I pick up pi over 6, I'm going to be at 0.5, so I can plot that on my graph. So the first one was 0, 0. This one's going to be 0.5. And I can keep moving around my unit circle counterclockwise, and I will be plotting the points as I go along. When I get up to pi over 2 or 90 degrees, I'm at 1. My y value is 1, so I have to plot that at 1. That's my peak, so I'm going to start coming down then again, and that's going to be this part here. So the first part of my graph from here to 90, so from 0 to 90, I'm talking about that part of the graph, and that's from this part of the graph here on the function. If I talk about the next part of the graph, so I can do that in yellow, from 90 to 180, I'm talking about this part of the graph here on the function. From 180 to 270, I'm going to get the part that's underneath. The reason that it's underneath the x-axis is because it's in the third quadrant, which means that the sign is going to be negative because the y value is negative. And then I can look at the fourth quadrant from 270 to 360. And if I go from 270 to 360, I'm talking about this part on my function. Okay, now I can continue to go counterclockwise around the circle, and from 360 plus, so we can go around the circle continuously, and then we can expand our x-axis on a graph. So if I add 2 pi to 360 plus 90 degrees, I'll get 450, and that'll take me up to there, and another 90, and I will get 540, and I can continue going around to get all my different degree angles and plot them on this point. So this graph here will continue forever. When I'm talking about the sine graph, I'm saying that it has a period of 2 pi, and by that I mean that it repeats itself after every 2 pi. So here I can see is one cycle. I can say there's another cycle back here. It's also a distance of 2 pi. This one would continue on for 2 pi also, take me up to 4 pi, etc. When I'm talking about the range, that's my y values, and it only goes from 1 to negative 1 to 1. So the amplitude we can determine from that is equal to 1. Okay? And the sine theta is an odd function, so it is symmetrical about the origin, so the sine of the negative angle theta is equal to the negative sine theta. Moving on to the cos function, okay, so if I look at my unit circle and I'm talking about my cos, I'm looking at the x-axis, I'm looking at the x-coordinate in the unit circle. So I can see here, this is my unit circle. If I'm talking about this point here, I know that it's 1, 0, so my cos is 1. Okay, so I can see that on my cos function, it's going to start at 1. Okay, and then if I go to 90, my x value is 0, so it's going to be down to 0 for pi 2, etc. And I can then work out the different sections of the circle. Okay, so the different sections of the circle, the first part of the circle from 0 to 90 is going to be this little section here. If I was to talk about from 90 to 180, it's this section here, which is the part that goes below. The reason it goes below is because I'm talking about my x-axis here, and that's in the negative numbers. The next one that I can look at is from 180 to 270. Sorry, I need to put my pen on. 180 to 270, which is going to take me from 180 pi up to 270, 3 pi over 2. And then the last part of the graph is in the fourth quadrant from 270 to 360, and that's a positive again up as far as 2 pi where it caps off at 1. Okay, the reason it caps off at 1 is if I look at my 2 pi, the coordinates at that point are 1, 0, because my x value is 1 and my y value is 0. So my cos is 1. Okay, and again, like the sine function, we can repeat this circle over and over again. We can find values of 450 degrees, 540, etc., and this will just continue on out the side, extending our x. So it goes from the negatives to the positives, and it will just continue to repeat. Okay, the range, however, will cap off at 1 and -1. So that's really, really important. And that's written here on the next page. So I can tell that, again, for the cos graph, the amplitude is equal to 1. Okay, and I can see straight away that my period is where it repeats one cycle. So from 1 at the top, which is my angle of 0, all the way out to my angle of 2 pi, back to 1 at the top, and then it starts to repeat itself again. Okay, so this here is one cycle, and it lasts for 2 pi, so that's the period. The tangent function, from previously our knowledge, we know that the tangent function is opposite over adjacent. So the tan is equal to opposite over adjacent, and if I think about my unit circle, I know that the opposite line that I'm talking about is this one here. Okay, so the opposite line is this one here, and that's my y, and this one down the bottom is my x. Okay, so if I'm saying the opposite over adjacent, it's going to be equal to the opposite is y over the x, y over x, and we know that our sine is our y and our cos is our x. So that's how I end up with this table here. Okay, when the cos is 0, that's going to mean you're dividing by 0, and anytime you divide by 0, you get an undefined answer, so tan will be undefined. This occurs every odd multiple of pi over 2, so that means we're going to have an asymptote at every pi over 2 multiple. Asymptote. Sorry, I missed my y. Okay, so again, I'm going to be looking at my different angles and checking out the values of the sine and the cos, and then working out my tan from there. So if I use negative pi over 2, I can say my sine is -1, my cos is 0. When I divide -1 by 0, I get undefined, so the tan of negative pi over 2 is undefined. I can do that for all these different angles, and I work out with this kind of a table. Okay, when I graph that, again, I can use this part here, using my unit circle, first, second, third, fourth quadrant, and I can work it out. So in the first quadrant, from 0, need to put on my pen, from 0 to 90, we're talking about this part of my graph here. It's going to approach the asymptote, but it will never touch the asymptote. So the asymptote, we normally write them in broken lines, like so, and it's going to occur every odd multiple of pi over 2. Okay, if I'm talking about the second quadrant, I'm going from 90 to 180, the 90 from 180. If I look at the angles from 180 to 270, I'm talking about this part of my function. And if I look at from 270 to 360, I'm talking about this part of my function. Okay, up as far as 2 pi. So it's the exact same thing, and it'll just repeat itself the more, oh, sorry, I don't need that extra red line, but basically it'll repeat itself the more you go around the circle. So you can just keep repeating that and extending out your x-axis. Okay. The amplitude doesn't have an amplitude, because the top of that yellow line and this blue line will continue on forever, and the same with the bottom of the green line, the bottom of the red line, they'll just go forever. So it's negative infinity and infinity, okay, the range from the y values, and the domain is any value of theta except when your cos is going to give you a 0. Okay, so therefore the odd multiples of pi over 2, and it's an odd function, so the symmetrical about the origin, and tan negative theta is equal to negative tan theta. So if I was to sketch the graph y is equal to cos x in the domain negative pi to pi, okay, I need to plot my points that I have so far. So I know that my cos graph normally starts at 1, so I can plot that first of all. And I know that it normally repeats itself by 2 pi. I don't need 2 pi in my graph at this point, I only need to go as far as pi. But I know that my amplitude is 1, so I can't go below -1, and my amplitude, because my amplitude is 1, and at pi 180 it's going to be at -1, okay, and at negative pi it's going to be at -1, and my -2 pi it will be back up to +1. Okay, so essentially that's what my cos graph will look something like this. Okay, but I don't need to go as far as 2 pi or -2 pi, so I just need to do the center ones, so it's going to look something like this. Okay, and that's all I was wanting, because that's all the domain I'm asking for. If I was asked to sketch y is equal to sine x plus 1, I can tell straight away from my equation that my sine graph has been translated +1, so it's going up 1 units. My sine graph normally starts at 0, so it would normally be at the 0 point, again at pi, and again at 2 pi, negative pi, 2 pi, and it would go to a max of 1, so it would be normally there, down to negative 1, sorry, up to when it's pi over 2, up to 1, and down when it's 3 pi over 2, down to negative 1, down to negative 1 when it's negative pi over 2, and up to 1 when it's, that's too far up, sorry, up to 1 when it's negative 3 pi over 2. That's my original graph. I don't want to plot it there anymore. I want every point to move up one place. So my new graph is going to start at 1, and it's going to go up as far as 2. My pi is normally going to intersect at 0, so that's now going to intersect at 1. My 3 pi over 2 normally hits negative 1. It's not going to go that far. This time it's going to go to 0. And my 2 pi normally hits 0, so it's going to hit 1. And I only need that domain, so that's all I need to do. That's my y is equal to sine x plus 1. Okay, so there's examples of how to sketch trig graphs, and you should be able to go from there.